There are so many different pieces of networking equipment out there, so much so that we can't cover it all in this course. However, we talked a lot about the basic networking equipment, and now we're going to talk about a lot more different pieces of networking equipment that are still really commonly used. Now let's talk about access points. Access points allows wireless devices to connect to the rest of your network without any cords or without anything else. It will send signals back and forth to this wireless access point to gain access to the rest of the network. Now, an access point is different than a wireless router. So I've seen a lot of times where businesses will use a wireless router in place of an access point. And the difference is the wireless router acts as both a wireless access point and a router, and so you're truly on a different network than the rest of your devices. Sometimes that doesn't cause a problem, but there are times when that can cause problems. So make sure that you're getting the right device for this. If you're connecting an access point to the rest of your network, make sure it's not a routing as well. Make sure it's not a wireless router. Then we have a wireless LAN controller. A wireless LAN controller would be a separate device that's on your network that helps you manage your wireless devices. So you would go onto this wireless LAN controller and then make configuration changes, and those changes then would affect the wireless access point so you can manage it all from one spot. Now, there's a couple ways that this happens is, once again, it does just what I said, but another way that you can set up this relationship is that any information that goes to the wireless access point gets then encapsulated and tunneled back to the controller, and then the controller then puts that information onto the network. So this is a common setup with a lot of wireless controllers, is that a computer will not go directly onto the network from the wireless access point, but instead all that traffic gets tunneled to the controller. The controller decides what to do with it and then puts it on the proper network and communicating to the proper equipment. This adds a little extra element to security, so that way your devices don't have access directly to just any network within your business. So then we have firewalls. You probably have heard the term before, you probably know a little bit about what it does, but firewalls protects your network from the rest of the world. It adds some safety protection to allow certain traffic to not be able to get inside of your network. And it allows some traffic to be able to go out of your network. Now, there's a lot of different ways to configure a firewall, but essentially most firewalls, a good portion of firewalls, are configured to not allow this traffic to come in. And then it does allow traffic to go out. So then there is the question, well, I'm requesting data and the data has come to me. How does this firewall allow certain traffic that I request to get to me? And we'll talk more about that as we go along through this course. But essentially, as a request goes out to a certain server, then as that information is being retrieved and comes back, that firewall keeps a record of what requests were made and allows that traffic to come back into your network. And so that's how it blocks most traffic from getting into your network, but does allow some traffic to get back if it's requested traffic. And so this is how a firewall is set up. Sometimes you'll see certain things like schools and certain businesses that will block most traffic going out and only will allow certain traffic to go out as well. This is an added element of security in case something was compromised. It wouldn't be able to go and establish a connection to an unknown server. But a lot of times these firewalls are set up to allow all traffic to go out and only certain requested traffic to come back in. All right, then we have intrusion detection system and intrusion protection system, an IDS and an IPS. They're two different things, and Sometimes you'll find that sitting on a firewall. Sometimes it'll be a separate piece of equipment altogether. And so an intrusion detection system will take a look and inspect or analyze the information that's coming in to your network, and then try to detect if there's some sort of traffic that looks really suspicious. Perhaps it's some sort of hacker that's trying to test different things out and test to see if it can wiggle into your network. And so an intrusion detection system will see that attempt and then will do some sort of alerting based off of it. So somehow it'll notify you, hey, you need to watch out for this traffic. It looks like that there's something going on. Versus an intrusion protection system does the same thing. It's looking for that traffic, but if it discovers it, what it will do is it will then block that traffic and stop that traffic from getting into your network. So it takes it to the next step and takes action on blocking that nefarious traffic from doing anything harmful to your network. So here we have load balancer. A load balancer distributes load among multiple servers. And so here what we have is we have a client right here, and it's going to make a connection to what it sees as some sort of server to ask for some sort of service. And what it's hitting is this load balancer right here. And then that load balancer is going to distribute the load among a couple servers or a few servers or many different servers. What a load balance does, it has several different purposes. But one of the things it does is it helps in case one of your servers goes offline, then you still have another server up and running. And so whatever servers are up and running, they'll be within that load balancer, and that load balancer then could just distribute amongst the ones that are still working. So that's one thing that it does. Another thing it does is it distributes the load so you can scale out rather than scale up. Sometimes what we see when we need to take a server to the next level, we have to upgrade it, and to upgrade it from one machine to the next machine could be a big step. It could be a big step up and pretty expensive step up. And so that scaling up is when you add more resources to a server to accommodate for more load. Versus scaling out is when you add more servers. And so now you can just incrementally jump up as your load increases. So two primary things that a load balancer will do is it'll have some sort of fault tolerance, so that way if a server goes offline, you still can have a connection and still be serving up services. And then the other thing is you can scale out rather than scale up. There's a lot of other advantages to it, such as you can take one server down for maintenance while the other server is up. And there's ways to make transitions from one batch of servers to another servers without having any downtime. So there's a lot of cool features to load balancing, but those are the two primary reasons. So a load balancer distributes the load amongst different servers. Now, one question you might have is, well, how does it determine which server it's going to send the information off to? And it has a few different mechanisms that will determine which server it needs to send to. The most commonly used is round robin, where it just sends it to server 1, then it sends it to server 2, then it sends it to server 3, then it sends it to server 4, and then repeats that pattern, or however many servers there are, repeats that pattern as it sends the traffic. But there are some more active ways of analyzing what the load is on each of the servers and distributing the load more evenly. So those are load balancers and how a request will come into the load balancer and then distribute it amongst multiple servers. A proxy server is set up so if a client makes a request, it goes to the proxy server, and then the proxy server goes and gets the information. The information comes back to the proxy server and then goes to the machine. There's several reasons why you would want to do this. For instance, maybe you want to make sure the information that's coming back in is secure and safe before it gets to your end client machines. But another reason is maybe you're doing some sort of web filtering and you want to make sure that people are not going to certain sites. And so that could be like a productivity, like if you're a business, it could be a productivity standpoint, or I've worked in a lot of schools and they're doing web filtering so that way it's keeping the students safe and keep them protected and keeping them from going to certain sites that they shouldn't be going to. And so what will happen is a request will be made to the server. The server will then look up to see if that site is safe to visit and if it should be visited, and then it will respond back. And if it's not a site that the student should be visiting, then it will send a little web page that says, no, you're not supposed to be visiting that site. If it is a site that's acceptable, they'll go and retrieve that web page and then send it back. So that's a proxy server. It's an in-between server that's going to actually go and make the request for the end user. Real quick note about the voice gateway again. The voice gateway is a separate gateway within your network, and we have phone lines. A lot of times now businesses are going to VoIP phone systems or voice over IP phone systems. So it's talking the same language as the rest of your equipment going through the same switches. But that traffic then gets put onto the voice network, which uses different protocols. So we have that gateway to transition from our newer VoIP systems into more traditional voice systems. Now, a lot of times we're seeing more of a transition now to it going through regular the internet and to get back to the voice systems. But sometimes businesses will still have that separate line or that separate gateway for their voice system. So then we have media converters. Media converters is just going to take a signal from one media and then convert it into another media. So an example of this is, let's say there's copper lines coming in one side, but we have this big long run that just a copper line is not going to be able to run that far. So we want to switch it to fiber instead. So a media converter will take that signal from the copper line and then convert it into a fiber line, and then on the other side it's got to be converted back so that way you can talk to the rest of your devices. So here we have a network here with two sides to this with our speaking through these copper lines, and then we convert this into a fiber line, and these are the media converters on each side that's going to facilitate that conversion from copper to fiber. Then we have modems. Modems are modulators, demodulators. What it's doing is your network is probably digital, and as it comes in, it needs to translate that to another analog signal that's going to go across a cable or going to go across phone lines. And so it's taking a digital signal and it's modulating it into something that a different type of network can use. And then when it comes back in from the other side, it will demodulate that to put it back onto your digital network. So here's an example of this. We have the internet here, and you have some sort of ISP that has a central office, which is a physical building where all the lines are coming into for phone services, and you have some cable that's going out to your house or some phone lines that are going into your house, and then you have your network that's speaking Ethernet back here. And Ethernet does not work well across these cables or phone lines. Hey, do you like my videos? If you do, please hit that like button because it really helps me out. And so what happens is this modem or modulator demodulator takes that signal, turns it into a signal, a waveform that can be sent across this cable or this voice line to the central office. The central office, if it's something like DSL and it's across your phone lines. And then the ISP will get you onto the internet so you can make a connection out to the internet. So this is the modem, and you can see the modems quite often are within residential areas to be that gateway to that other network. All right, now let's talk about a MUX, or a multiplexer demultiplexer. A multiplexer or demultiplexer is going to take several channels from one side, combine it onto one media, and then split it out on the other side into several channels again. So perhaps we have on one side, let's just use 4 channels as an example, but this could be many different channels. It could be 24 channels, it could be 48 channels, it could be a lot of different combinations here. So let's just use the example of 4 channels, and it needs to combine them. So it's going to take those 4 channels, and this MUX is going to combine them on one line, and then on the other side you have a demultiplexer, or this MUX on this side will split it out into 4 channels again. And it does that many different ways. There's the different ways that you can do this. Perhaps maybe there's some sort of timing where it devotes a channel into a little time slot as it sends it over. So you'll see this pattern of 1, 2, 3, 4. It gives them a little time slot, and then it repeats that same pattern again. And so that's one example of how that could be done. Another example is they actually have a way that will take different color or different wavelengths of lasers and be able to send it across one fiber and then be able to split that back out on the other side. So a MUX is a multiplexer demultiplexer and is capable of sending data down this line from multiple channels and then splitting it back out on the other side.